In this video, we're going to look at the importance of choosing the right implementation of a list for your application. So in particular, we're going to add 100,000 items to an array list and then to a linked list and time how long it takes to do each of those things. So if you've looked at the PowerPoint for this topic, which I really hope you do, one of the things it talks about is how to add an item to an array list. When you add an item that's not at the end of the array list, you have to scoot everything that's currently in the array list over by one space to make room for the new item. So in this case, we're adding a new item at index 2, so I have to scoot everything that's at index 2 and later over 1, and then add the new item at the space that I've opened up. So you can see that the worst case of this is when I add an item at index 0, which is the beginning of the list, because then I have to move everything that's currently in the list over one space so I can make room for the new value. This is order n, where n is the number of items in the list, because I have to move everything in the list. So that's order n to add a new item to the beginning of an array list. To add a new item to the beginning of a linked list, it's much simpler. All we do is we create a new node to represent the new item, and then we point that node's next pointer at the current head of the list. So we have this right here, and then we just move the head to point to the new node that we have. So this is order 1, or constant time algorithm, because it doesn't matter how many items are in the list. We always just do those same 3 steps, and they always take the same amount of time no matter how big the list is. So let's look at some code that does that. So I'm going to make 2 lists here, an array list of integers, and then we'll also make a linked list that holds integers. And I just need to import these classes so that I can use them in my program. Okay, so we're going to make a for loop that goes from I is 0 to 100,000. And each time through, we're going to add a new item to the array list at location 0. I'm going to use a random number generator to generate the items we're going to put in there. And I'll just seed that with the current system time. Okay, so there we've added the items to the array list, and I'm going to do that for the linked list as well. And now I'm going to put some code around here that's going to time how long these different things took. And we'll just do the same thing for the linked list. Okay, now let's run this program. So we can see that for the array list, it took nearly 7 seconds, whereas the linked list was more than an order of magnitude less. So it's very important to choose the correct implementation for your application.